Okay, good evening. Welcome to
MinuteMath number 175.
MinuteMath number 175. This is an awesome problem, even though we haven't talked about geometry too much. A very awesome problem. An equilateral triangle and a hexagon have equal perimeters. What does that mean?
What means the distance around the edge is the same.
Around the outside edge.
Yeah.
If the area of the triangle is 4, what is the area of the hexagon? Ooh, awesome.
So we have an equilateral triangle.
Yeah, and you know what a regular hexagon is? Or did I even write regular hexagon?
Well, it means all the sides are the same.
Yeah, sorry, I meant to write regular hexagon. It means all the sides are the same and all the angles are the same.
Well,
They have the same perimeter.
the area formula for a triangle is 1/2 base times height.
Base times height, yeah, but you know what? Unfortunately, we have not talked about how to find the area of an equilateral triangle.
Well, isn't this the height though?
It is that right, that is the height.
Well, we don't know how to find it.
Don't know how to find it, but you do know that the area of the triangle is 4, and you do know that the perimeters of the triangle and the hexagon are the same.
How does that help us?
And you're absolutely right on the first step is going to be draw a picture here.
So we know they have the same perimeters,
You know they have the same
and we know
perimeters.
the area of the triangle.
Right, so you know the same perimeters. Very good.
But we need to figure out what the perimeter is.
Same perimeters. Area of triangle. Okay?
We need to figure out what the perimeter actually is.
All we need to do is figure out the area of the hexagon, actually.
Yeah, but it might be, well, we don't know how to find out areas for hexagons.
Ah, interesting. So there's a problem. We don't know how to find the area for hexagons. And of course, again, I meant regular hexagons. So why don't you draw a regular hexagon a little bit bigger?
So,
Close. Close. Yink, 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 yink. Okay. So there you go. Now you know all the sides are the same and all the angles are the same. How are we going to find that area of this thing?
well, we can split it into triangles.
We could split it into triangles like that. That's true. That's going to be interesting.
But it might be hard to find the area.
Yeah, that's going to be hard. See if there's another way you could split this hexagon up into pieces that might make it easier. And I'll give you a hint. There's also an equilateral triangle hanging out over here, whose area is 4 and whose perimeter is the same as the perimeter of that. So try again on how to split up a regular hexagon.
Well, we can cut it in half.
Oh, interesting. Cut it in half that way.
And we can cut it into fourths.
Okay, go ahead. Now that cuts it into 4 pieces, not necessarily into fourths.
Yeah. We have 2 equilaterals,
Ooh, interesting.
but we can cut it.
Oh, wait a minute.
And we get a lot of triangles.
We get 6 equilateral triangles here. Hey, we have an equilateral triangle over here. Now maybe we can figure out how this is related to one of those. So we
We found
know.
out what the base was.
Interesting. Well, you're not going to be able to figure that out,
Yeah.
unfortunately. We haven't talked enough about geometry, but you do know the perimeter here is equal to the perimeter around that thing. So how is that going to help you?
Well, the perimeter of one of these little triangles is the big thing. Would it be the big thing divided by 6? No, wait. The perimeter, the length of this base
Yeah?
is the perimeter divided by 6.
Okay, very good. So what do you want to call that?
I call the perimeter P.
Okay, so that's P over 6. What's the length of one of the sides of the triangle?
It's P over 3.
Interesting. So what's the side length of this triangle compared to the side length of this?
It's twice as big.
So if this is x, this is 2x. Okay, now, challenge question. When I cut the side length of a triangle in half, and I have a triangle that has sides x, 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 and that area is 4. Oops, sorry, I said it wrong. 2x, 2x, 2x. That area is 4. What's the area of a triangle whose side is x, x, and x? What do you think?
Well, maybe 2.
Okay.
But we don't know what the height is.
Well, we do know it's the same as this equilateral triangle, except each side is half. Now, interesting. So your guess is the area of this is 2. Let's take a look at a square. Let's say I had a square whose side was 4, 4, 4, 4, and another one whose side was 2, 2, 2, 2. What's the area here?
16.
What's the area here?
4. So maybe it would be divided by 4.
Ooh, why would it be divided by 4 instead
Because
of divided by 2?
an area is something x squared. It's in,
Okay, for a square.
it's in square units.
Right, and then for the triangle, we have base times height, but the base is half and the base is twice as big, that means, and the height is twice as big.
Mhm.
Base is half, height is half, so you divide by 4, so the area of one of these triangles is 1. So what's the area of the hexagon?
It's 6.
6, there you go. That's a cool problem. A lot of stuff going into that. Shows you some neat ideas in geometry. Alright, good job. That's a tough problem. That's problem number 23 from the AMC 8 last year.